learn in a week or 2 weeks or 2.5 weeks. But I do want to kind of move forward, if you will, into our next topic. We're not going to leave estimation behind, but there are times when you can't estimate. There are times when you actually need to be more exact than 15. Okay, like when you're building a road, for example. When you're building a road. How many of you have seen a sign like this? Yes, some of us seen a sign like this. Yes, good, good, good. 6% grade. And that's the word I want to focus on today. I want to focus on that. I want to make sure when you guys walk out of here today, you understand exactly what that means. Who knows what it means right now? Or at least has an idea of what it means right now. Please.
It means that it's going to be a steep incline, that you're going to be going down a hill.
Good, good. This looks like a downgrade. I'm thinking with the truck pointing down like that, it's a down. I hear steep incline. Andrew, were you up there too?
Yes, basically it's just 6% down.
Good. What does it mean, 6%?
It's, if you're flat at a 90-degree angle, it's basically 6 degrees down.
Okay, boom. So we have vote for a steep decline, steep decrease. If you're at flat is a 90-degree angle, that would be 0. 6% would be 6 degrees. Good. Who else? Other ideas on grade? I want to hear what you think about it right now. I mean, in anything. It doesn't have to be mathematical. Just what do you think? Do you think, oh crap, I better check my brakes? Please, Kirsten.
Well, I've heard that it, I don't know, to get to 1,000, to get up 1,000 feet, it'd be like, I don't know.
You're damn close on that. Think of it that way. You're damn close. There's an interplay between the definition that Andrew just gave us and the definition that you're kind of halfway giving me, right? There's an interplay between those. They're not exactly the same, but they're two different ways of saying the same thing. So here, I want to use an example first. Here's one that you might recognize. You might have been on this today, as a matter of fact. Recognize that road? Oh, that's a little dark. How's that? Is that good? Is that too dark for you guys? Are you going to sleep on me? No, you're right. Wake me. What road?
College Way.
That's College Way. That's heading up College Way. I would guess that's almost to the school. That's almost to the school. And yeah, I think we're about halfway up. What do you think the grade is on College Way? 10%. If you had to pick a number. 10%. 10%. 3%. 5%. I'm also, I'm asking, I didn't use this word, but I should throw the word average grade in there, not just grade. And the reason I say average grade will be more clear when I show you Archie Briggs in a moment. But grades of roads are rarely consistent. They're very rarely exactly the same the whole way. They undulate a little bit, they go up, they go down, they flatten off. But the grade, which we'll discuss mathematically here in a moment, can be averaged over an entire distance. College Way, surprisingly, is pretty consistent from bottom to top. It's almost exactly 6%. It's almost exactly 6%. So the question I have is, what is that 6%? Is it an angle? Is it this 1,000 feet thing Kirsten was getting at? I like that too. That was good. That was good. So what I want to do is, I want to make sure we understand what that definition is. So let's swing over to here. So we're going to need some more board. We'll come back to the PowerPoint too, because I got a whole bunch of other examples I want to look at, which I think you guys will enjoy. Let's drop this. This is one of those things, having infinitely many adjustments, none of which really work.
Is it on?
It's on. It sounds like the tech guy I was working with last week. I can't dump the memory card. Is it turned on? Yes. It's telling me the crap is in there.
I just didn't remember you coming back over here.
No, I just had a flashback to that guy. Like treating me like, it was so funny because I could tell he was dealing with people all day long, like turn your camera on. Oh, thanks. I could totally tell. So, College Way. College Way, or any road that you drive on, essentially is a hypotenuse. What the hell is that? The hell is a hypotenuse? It is Greek. Ha! Who said that? Sounds Greek. It is Greek, Di. It is a Greek word. What does it mean?
Longest leg of shape.
Ah! What kind of shape?
Triangle.
What kind of triangle?
Right triangle.
Boom. It's the longest side, longest leg. Can I say side? Because the legs are actually the other two by mathematical definition. So longest side of a right triangle. So if we draw a picture of a right triangle, when it says right triangle, what does the right mean? R-I-G-H-T.
At least one corner has a 90-degree angle.
Boom! And in Euclid's world, thank you, Di, in Euclid's world, exactly one. You can actually, believe it or not, you can have triangles with more than one right angle in them.
They look odd.
Not in Euclid's world, but think about a globe. Think about a globe, and think about lines of, what the hell are they called? Is that latitude? Longitude, thank you, longitude. Think of lines of longitude. They start at the equator and go up and intersect at the North Pole. At the equator, they're both form at 90-degree angles, and there's an angle up top that's not 0, that's actually bigger than 0. So you can have a triangle with more than 180 degrees in it, just not on a flat surface. Go ahead, Micah. Not on a flat screen, you can't. That's what I'm saying. Euclid's geometry, which we're going to use today. Euclid's geometry. Euclid is the great granddaddy of geometry from way back in the day.
What happened to Pythagoras?
Pythagoras, does he predate Euclid? I forget. It doesn't matter, you're right. But the fact of the matter is I can't draw it on a screen because I need a curved surface to draw it on. You need a globe, a sphere, spherical geometry. So here is a right triangle. Okay, I'm going to pull this out of the here right now. This would be the right angle form. You use right triangles all the time. All the time. Have you ever used a rectangle idea to square up a wall? Or you've laid out dimensions on a plot or a plat? You've used right triangles because they lock in 3 sides at fixed distances. If this is the road, though, what part are we driving on? Hence the hypotenuse. We're driving or traveling, as I am driving or traveling on this, which is the hypotenuse. The other 2 legs, you never actually touch unless the road is completely flat. If you're on a completely flat road, the hypotenuse is going to lay smack down and lay on the horizontal leg. And if you're driving on a completely vertical road, which please, everybody try that, you're going to be riding on the vertical leg and you won't have a hypotenuse either because it's going to be dead vertical.
But there's no right angle, so why would there be a...
Say that again.
hypotenuse?
That's what I'm saying. You're always driving on the hypotenuse unless it drops down flat, in which case the triangle disappears. In which case there is no, well, the grade is 0.
Okay.
And if you're dead vertical, there is no grade. And thankfully there are no roads that do that. There are cliff bands that do it and stuff like that. Does that make sense, Kirsten? Good. Now these are called legs. They are. But I'm going to call them something else if it's okay. Because if I just call them legs, you guys might mix them up. So I'm going to use another word, or 2 other words you guys already remember. Rise. And boom! See, I told you you'd do it. Rise and run. That's the words we're going to use for those legs. I mean, yeah, they're legs, for sure, they're legs. But we're going to use rise and run because, number 1, those words have context. Rise, run. So rise almost implies vertical, run almost implies horizontal, which means we then have direction of what we're measuring. And here's why I like it even more. The definition of grade is defined to be simply the ratio of the rise over the run. And you've seen that before, haven't you? But you didn't call it grade. And this is crystal. Yes, you called it slope back in the day. You called it slope. I'm going to do that different color. Purple marker, go. Slope is another word you used to use. Sometimes the letter M is used. Yeah. Your TI. Yeah. I have no idea why. Very often I can figure out why certain letters are used in mathematics because they're contextual. I have no idea why M is used. I guess S was taken. Your TI actually uses little a, which is much more logical. We'll come back to that next lesson, linear modeling. We'll come back with that. But right now, I just want to call it grade. Why do I want to call it grade? Why do I want to call it grade? Is it because I'm a bastard? I'm making up new terms just to torture you with a new term, Micah?
Is it because of a specific formula?
It's not a formula at all. It's conversation. Outside of mathematics classrooms. Say that again, Jordan?
Real life.
It's basically, yes, it's the word that most people in the outside of academia world use to discuss this idea is grade. You have a grader. Think about the big machine with the big blade on it that is sometimes uses GPS to make sure it's precise enough. It's my son's favorite, I think, besides the excavator. It's not called a sloper. It's called a grader. Okay? When the road's percentages are given like this, it's given as grade, not slope. We very rarely talk about the slope of the hill or the road. We talk about the grade of the hill or the road. Why slope is used? I don't know. Mathematicians like to call it slope. But the rest of the world calls it grade. So I want to kind of get you in that habit of thinking about grade calculation. Fair enough? So that, when you see 6%, what that means is the road rises 6 for every how many that it runs. For every how many that it runs.
Miles.
And this is where, well, how many? That's my question, is how many? See, it's 6%. And this is one of the reasons I have you do that little pre-req quiz. The first thing you have to do, here's an example. College Way.
Well, I think it's gonna take 6 miles to get up 1,000 feet. I don't.
Close, damn close, damn close. You gotta get the 6 and 100 in there somehow, right? Good, hold that thought here, you're about 30 seconds in front of me. Thank you, very nice. It's our mistake. It's a 6% grade. 6% grade. Now, as a mathematician, I am fundamentally opposed to that symbol. I hate it. I despise it. It's dumb. We are inundated with it on a daily basis, but it's dumb because you can do nothing with it. What's the first thing you have to do with that symbol before you can do any mathematics on it whatsoever? Micah? You have to convert it to a what? A decimal or a fraction. Or a fraction. I like decimals though. I like decimals because we can just, it's very simple to change that to a decimal, isn't it? What's 6% as a decimal? Boom! That's 0.06. Now the percentage symbol is out there. We have to deal with it. It's one of those things we have to live with. Whatever, it's fine. But 6%, 0.06, we have to convert it to that first. Once it's a decimal, we can then form the ratio of 6 to 100, which is our fraction that Jordan brought up. I like going to the decimal first. I think it was Jordan. I heard a voice over here. I like going to the decimal first and then converting that to a fraction because 6% as a fraction directly, you guys might call it 3 over 50, and that's totally fine. But nobody ever messes up going from a decimal to this decimal to that fraction because it's simply a matter of putting 100 on the bottom. All right. So what does this mean? 6 to 100. What does that mean? And there are infinitely many correct answers for this, just so you know. Please, wait, wait. Michael. No, this is not Harrison, he's at 243. Thanks here. Damn it, help me.
David.
Say who?
David.
David, I don't even close, it's my damn middle name, go!
So you ride 6 feet over 100
Over 100 what?
feet.
Boom! Notice how grade has no units. It's not feet, it's not miles, it's not kilometers. That's because the units cancel. So check it out. What David just said was, he said, one interpretation of this would be that we rise 6 feet. I'm not going to use a symbol. Smile, tackle it. Rise 6 feet for every 100 feet of run. Love it. Love it. What's another way to interpret it? Using 6 and 100. You got to use 6 and 100, Andrew.
It doesn't matter. It could be 6 miles over 100 miles.
It could be 6 miles over 100 miles. 6 miles over 100 miles. What's one more way? Kilometers. Very nice. Yeah, just go your opinion on it. 6 kilometers over 100 kilometers. And it doesn't matter what units you use, because they're going to cancel off anyway, because you're using the same unit. What you don't want to do is do something like 6 inches over 100 feet, or something like that. That's how we bury Mars rovers, or ask NASA about that when you get units mixed up, right? That's it. Or Spinal Tap built to Stonehenge, it's just big. So you just make sure you're using the same unit. I don't care what the unit is, and here's why I don't care what the unit is. I'm going to give you a little bit of a geometry lesson, a little teeny tiny bit of a geometry lesson, sorry. I don't know. The rise and the run have this relationship of grade. Now, Andrew, I haven't talked about your angle yet, but I will. I promise we're getting to that. I do promise we're getting to that. There is an angle formed right here. Okay? I'm gonna put it in quotes, because it's got different names. Sometimes it's called angle of incidence, sometimes it's angle of inclination. I mean, there's all kinds of different words you can use, but it is an angle that's formed. Here's the deal. Suppose, what's the biggest one here? Miles, right? Yeah, miles bigger than a kilometer. Let's suppose first of all, I apologize for the scale of this figure. Anybody pissed off about the scale of this figure? It's definitely not 6 to 100, is it? It most definitely is. If this is 6, what's the bottom? 6, 12, 18, 24. So I'm definitely exaggerating the vertical rise of this. So I apologize, YouTube, I apologize for the disproportionate, but it gets very hard to write things inside if it's not skewed. Fair enough? We'll get to that angle in a second, Andrew, I promise you. So let's suppose that this distance represents 6 miles. That means this distance down here represents the 100 miles. We'll come back to that hypothesis in a second. Where would a kilometer or 100 kilometers be? Where would 100 kilometers be?
Where the miles are.
Well, a kilometer is roughly 2/3 of a mile-ish, somewhere.
Further back.
Good, good. So what you would do is, if you wanted to indicate kilometers on this thing, pick somewhere, put it in here-ish, somewhere about there. This distance here, forming a right angle, that's a straight line, forming a right angle would be 6 kilometers. That'd be 6 kilometers. Where's the 100 kilometers going to be? Where's the 100 kilometers going to be? Oh, where on the bottom? Ariel, help me out, help me out.
Just that distance from here to where you do the line.
There we go, this guy right here, right? That's your 100 kilometers. That's your 100 kilometers. And if you wanted to use inches or feet, that's totally fine. We're blow it up and make it a little more ridiculous. Here's 6 feet. Where's your 100 feet? Want to use 6 inches? What would this be here? 100 inches. It does not matter what unit you use. It also doesn't matter if you go 6 to 100 or 3 to 50, 2 to 25 and a half. No, 1.5 to 25 and a half. There we go. It doesn't matter to me what distances you. 1.5 to 25. There we go. 1.5 to 25. Woo! Totally doing math in my head. 1.5 to 25. It doesn't matter as long as what stays the same. Say it again, Kirsten, nice and loud. The ratio has to stay the same. That's the only thing that has to stay consistent. It does not matter how you measure it. The easiest, it's very easy to do though. It's very easy to drop maybe kilometers over miles or something like that. Especially because in program, I'm going to have you guys look at one of these soon. In programs that track elevation, I took one on my that bike ride I did last weekend over Mackenzie Pass. Horizontal axis was measuring in miles, vertical axis was measuring in feet. And you look at that, you're like, holy crap, I'm a beast. And like, no, convert it. You convert the miles to feet, and you're not as much of a beast as you think you are. Because it looked much more exaggerated when you brought these down into miles and let this stretch out into feet. Does that make sense? Yeah. So you have to make sure you're keeping those things consistent. Fair enough so far? That is the definition of grade. Here's a few more. Let's start and stop.